Okay, thank you very much. Well, there are three classes of network operators that I've been bumping into lately. The first class doesn't require any traffic engineering at all. And if you're a member of that class, open your beer now. You really don't need to pay too much attention. The next class requires very fine-grained traffic engineering with bandwidth reservations and different policies at each ingress node. If you are a member of that class, you need segment routing, you need maybe you need RSVP. If you're a member of that class, open your beer now. Then there's a third class that's somewhere in the middle between these two extremes. They need a little bit of traffic engineering, maybe to keep traffic in one plane or another, maybe to follow high bandwidth or low latency paths. They want a simple solution to traffic engineering, to the traffic engineering requirement that they actually have. They don't want encapsulation. They don't want MPLS. They don't want something that's incredibly complicated, just enough for their requirement. And for that middle class, I'd recommend you hold off on the beer for just another 20 minutes, and we'll talk about Ipflexalgo. So let's take a look at a typical Ipflexalgo use case. Here we have a wonderfully rectangular network with 4 nodes, R1 through R4, and its links are colored either red or blue. Now, it has 4 flows that traverse from R1 to R4. The red flow traverses red links and no others. Orange flows prefer red links. They'll take them when they're up, but if a red link is down, they'll take an alternative route through a blue link. A blue flow traverses blue links and no others. And a yellow flow prefers blue links, but it can fail over to a red link. So imagine this as maybe flows that, maybe the red links are high latency and the red links are low latency and the blue ones are high bandwidth, or maybe one plane or another. This is the kind of use case that we can address. Now, how do we address this? Well, it's done entirely with IGP magic. And in fact, the magic is pretty simple. The IGP advertises information about nodes and the links that are attached to it. And for each link, we advertise 3 things. We advertise an IGP metric, we advertise a TE metric, both of these are configured, and we advertise administrative groups, in this case, red or blue. So, and this goes on today. There's, nothing particularly new about this for Ipflexalgo. Now, the next thing is a few nodes within the domain, generally 2, maybe 3, will advertise Flexalgo definitions. Now, these Flexalgo definitions are concepts that are plagiarized from segment routing, because segment routing has Flexalgo. Well, here we apply Flexalgo to IP networks without segment routing. So what does a Flexalgo definition look like? Well, one of them is the red Flexalgo. It uses only the IGP metric. Remember, we had 2 metrics for each link. It'll use the IGP metric. That's to be compared with the blue Flexalgo that uses only the TE metric. They all use SPF route calculation. And each Flexalgo definition has a constraint. For instance, red excludes blue. So when red calculates the path, when any node calculates the path to R4 using the red algo, it will make believe the blue links aren't even there. Orange FAD will use all links. So what you're seeing here is basically the Flexalgos that will only travel over one color exclude the other. The Flexalgo that will use one color but fail over to the other include all. So now we're going to pull it all together. R4 has 4 different loopback addresses, and each loopback address is associated with a Flexalgo number. So R4 advertises 4 prefixes: loopback A associated with the red FAD, loopback B associated with the orange FAD, C with blue, and D with yellow. R1 calculates the least cost path 4 times, once for each FAD prefix combination. So let's take a look at R2. It's going to calculate the its best path to R4 4 times, once for each loopback address. And it's going to use the constraints that it learned in the associated FAD. So what does this look like? Let's take a look at R1's routes to R4. If it's going to the red loopback address, its next hop is R2, and it has no failover because the red FAD excludes blue links. If it's going to prefix B, which is in the orange FAD, its next hop is R2 still, because the orange FAD uses IGP metrics. And because the metrics are lower on red links. And there is a failover through R3 because the orange FAD includes all links. Now, take a look at R1 routes to R4, the remaining 2 routes to R4. Via segments, via the blue path, the next hop is R3, and there's no failover because the blue FAD excludes red links. But to segment D, the yellow one, the next hop is R3 because the orange FAD uses TE metrics and because TE metrics are lower on blue links, and the failover is R2 because the yellow FAD includes all links. So basically, what we have here is a simple example of how you can use Ipflexalgo to keep traffic in one plane or another and let it fail over as you want according to your policy. So if you want to know more about Ipflexalgo, take a look at the internet draft that we talk about in the upper right hand of this slide. Draft IETF LSR Ipflexalgo. The nice thing about it is it works with plain old IPv4, IPv6 network. You don't need MPLS, you don't need SRv6, you don't need RSVP. All you need is IP and your favorite IGP. The trick is that there are multiple loopbacks, and you associate each loopback with a Flexalgo. We use the FAD procedures from draft LSR Flexalgo, which is SR Flexalgo, and we reuse the computation procedures from the same draft. Loopbacks corresponding to Flexalgo follow the specific path, and the next hop is computed based on the Flexalgo. Now, let's say for a minute you have a service prefix. Let's say for a minute that those loopback addresses are next hops for BGP routes. It all just works. If you associate a route with a loopback address that is associated with a Flexalgo, traffic to that route will follow the path that the Flexalgo calculates. So the conclusion here, Flexalgo is powerful. Many network operators only require this coarse-grained TE. They don't need all the TE capabilities of segment routing or RSVP. So this works pretty well. And the benefits: no MPLS, no large address blocks per Flexalgo, no new protocols required. This is only a little bit more IGP magic. There right now is a demo available from Juniper, and although I can't speak for other vendors, I know that they've certainly received it well, and you can probably talk to your SEs and get demo code from them. Right now, we don't have a date for an interop event, but in the near future, we will be testing with other vendors. And with that, I'll go to questions.
Thank you very much, Ron. Do we have any questions, Leo, for Ron about Ipflexalgo?
We don't have any questions in the queue yet, but perhaps someone wants to mention that they're going to ask their question directly, and they can raise their hand and I will unmute them.
I think I'm standing between a group of engineers and their beer break.
Yeah, I don't see any questions. So, Marek, I'm going to hand it back to you.
Thank you, Leo. And thank you again, Ron, for your fascinating talk about Flexalgo and how to do traffic engineering without necessarily having all of the trappings of an underlay or overlay network.